Good morning, all of you. So today I'm just going brief you about a topic in a machine learning, a very important topic. Okay. Myself, I am Manish Kumar, assistant professor in Department of Computer Science and Engineering at Kumar Garg Engineering College. So today I will brief you about, firstly I will brief you about the definition of machine learning. What is machine learning? Then what do you mean by well-posed learning problem? Some example so that you can understood how we can define a learning system. Okay. Then finally a most important topic, that is how we are going to design a learning system. Okay. So let me start with the definition of machine learning. So we all know that machine learning. So what is machine learning? This machine learning is built with two words, machine and learning. We all know machine, a mechanical device, any machine, electronic device, electrical machine, any machine. So here what we will do, we will just design an algorithm. We will use several approaches to teach a machine ki how it will work. Okay. So what I can define easily, that a machine learning can be defined as a multidisciplinary topic, multidisciplinary subject, where we can find sense of all the different subjects. For example, we can machine learning already associated with computer science and engineering, CSC. You all heard about artificial intelligence, AI. You all heard about, we can see the flavor of artificial intelligence here in machine learning. In machine learning, we can see economics, psychology, cognitive analysis, stats. So all these different subjects were give a flavor of machine learning, build a machine learning. So for designing a machine learning algorithm, we will use several approaches here. So how first, but we should firstly define how we will write a machine learning definition. So according to Tom Mitchell in 1993, he gave this definition that a computer program is said to learn from experience with respect to some task, class task, that task T, and a performance measure P. And if that performance at task in T as measured by P is performance measure, it will improve the experience E. So I have highlighted these three words, this experience E, number one, number two is task T, and number three is performance measure P. So just keep in mind these three factors, three important points: E for experience, T for task, P for performance measure. These three important points build up the definition of machine learning. Okay. So this definition was given by Tom Mitchell. Tom Mitchell. Okay. So why we use, why we need to learn, why we use to learn? Because where machine learning is needed, learning is used when human expertise does not exist. For example, where, for example, if a man goes to a Mars, so we send a machine to navigate what is the environment there, what is the soil there on Mars. So what we will do, we will just teach a machine, and that machine will go there and summarizes all the environmental issues there. So here expertise doesn't exist, human doesn't exist, so we will send a machine. So this is the requirement. So we need a learning here. Okay. Secondly, second example, humans are unable to explain their expertise. For example, speech recognition is also an important. For example, we are just living in a country where different caste and creed exist. So speech means what? People used to speak different languages. So one can't be expertise in knowing all the languages. So here we need a machine which can just translate all the languages. So here we need an expertise. So what we will do, we will just teach a machine here. Okay. Third example, why we need to learn? Solution changes in time. Where solution is changing? For example, routing on a computer network. So we know that in a computer network, a routing algorithm is needed. So we will just teach a machine where, for we can take an example of says mobile network. So we have seen that a lot of the calls were dropped. So there is also some routing algorithm is implemented, है ना. So the solution is changing with time. Third example, a solution need to be adapted to particular cases. For example, using a biometric system. For example, each and every human being have its own impression. So every thumb impression is different. So what machine has to learn itself that will recognize the thumb for each and every person. So here we need a learning. So first of all, we need to know why what is learning. So here in machine learning, we will understood it like a concept. Okay, because what is the concept means? Concept means that, for example, it is defined as a Boolean valued concept. Boolean. When we talk about Boolean value, Boolean means there are two values, 0 and 1. So here in machine learning, we will prove that learning is defined as a concept, a Boolean valued concept. For example, if a system exists, if true or false, and true means yes, false means no. So we will summarize it as a learning system. Okay. So these are the examples where you can understood that why we need learning. Okay, students. Now next. So before teaching a machine how to build a learning environment, building a learning system, we should know how this learning problem can be posed. So by the definition of a machine learning, we know that we have the three important factors, that is a task, second is performance, and third is experience. So this is we will make a computer program. So computer program, we will assign a problem, means a task, okay, and we will see how that performance will be improved. This is T, this is P, and with that improvement, what experience we are getting, E. Okay. So for example, I just illustrate an example. For example, I have planned to come today college via a car. Okay. So usually I used to take this public convenience, है ना, public by bus I used to travel, है ना. But now today I think I was thinking that I will go via bus. So what happened, when I used to think that I will go via bus, I was little bit lazy. Okay, I just take my car and just start going to college. So what I'm seeing my watch, and my college timing is 8:30. So what I think that I'm just going to reach college at 8:30, but I'm getting late. So what I will do? I will just push the escalator hard. है ना? I'm just I'm driving the car at the speed of 80 and 100 miles. Okay. So what happened? I just going to approach the college, and what happening? This in front of the college, a truck is crossing the road. I just applied my brakes very hard. I feel very I feel very unconscious that how this car will be stopped. So what happened? I just managed to stop my car at the last moment before the truck crosses. So what happened? I just stop my car. I just come out from the car and I just relax. Oof. And I just committed on that day I will not drive a car exceeding the speed more than 80. I just take the commitment of myself. So what is this? This is my experience that I feed in my mind. So next time when my another friend want to drive a car very fast, then what I will do? I just say him, stop, do not drive car very fastly. So that is the experience that feed in my mind. So in the same manner, we will teach a machine by feeding an experience. So as the time spent, the experience will go on and we will improve the system performance. So for this, we will take these three important factors, three important features: T for task, P for performance, and third is experience. Okay, students. So here you will get a glimpse by I have given the first example here. For example, I am going to design a learning system for a checkers problem. Okay. So what is the task here? Task is I am going to playing a checkers. Okay. What is the performance measure? Performance measure will be calculated on the basis of the percentage of games won against an arbitrary opponent. This is the performance measure. And after that, the experience is that the playing practices games against itself. So by playing the game itself, the experience is improved. Okay. So this is the first example. Second example is, for example, I am going to design a program for a handwriting recognition problem, learning problem. So for that, what is the task? Task is recognizing the handwritten words. This is the task. And what is the performance measure? Performance measure is the how many words are easily classified by that machine. What is the percentage of words, है ना? And what is the experience here? Experience is the database of human labeled images of handwritten words. Okay, this is the second example. Okay. For example, third example is robot driving learning problem. Means I just want to design a learning program, computer program, which will instruct how we are going to drive a driverless car. So what is the task here? Task is that I am going to drive a car in a 4-lane highway using a vision sensor. Sensor is there, na? For example, sensor is used for detecting the images. So this is the task. What is the performance measure? Performance measure is how before coming any error, matlab how much distance was covered by that car without the driver. This is the performance, average distance traveled before a human judged error. Okay? And what is the experience? Experience is the what are the sequence of images recorded by that camera while observing a human driver. Okay? This is the third example. Fourth example is email learning problem. What is the task here? Task is that I am just going to identify whether I getting the spam, my legitimate emails or spam mail. What is the performance? Performance is that email messages were correctly classified as a spam or we will just make the different labels. You have used the different labels na, in your inbox. That the proper mails will go inbox, spam will go separately, advertise mails will go separately. So we are designing the system. Third is what is the experience? Experience is that we just make a database of email with that given labels of that labels we have decided. Okay? So these are the 4 examples through which you can understand how we are going to define a learning problem. So these 3 components, these 3 features were taken from machine learning definition. T for task, P for performance measure, and E stands for experience. Okay. Now what we have to do, we have to just design a learning system. This topic I was saying, this is very important topic. So now I'm just briefing you about how we are going to design a learning system. So for designing a learning system, we have to keep in mind these 5 points. Number 1 is, firstly we just choose the training experience. Okay. After choosing the training experience, we will choose the target function on which the behavior will be dependent, that how will machine will behave on the basis of that function. Third is the representation for the target function. Okay. Fourth is how approximation algorithm, what approximation algorithm we are going to use, and what this approximation will do. This approximation will estimate the training values and adjust the weight, and at last we will get the final design. Okay. So first of all, I am just discussing this using this checkers problem. Okay. I am giving you an example of this checkers problem for designing a learning system. Okay. See, this is the checkers game. I think you will all recognize by seeing this diagram. Okay. So I am just going to design a learning system for this checkers problem. Okay, students. Now, number 1, our first point is, firstly, what we will do, we will just choose the training experience. This is the first design choice that we will choose here. Okay. The type of training experience available can have a significant impact on the success or failure of the learner, how it will learn. Okay. So this is the first point. So under this training experience, see how we are going to choose a training experience. There are 3 key attributes. What are the 3 key attributes? These 3 key attributes will fully responsible for the success and failure of the learner. How that learner will going to. Who is learner here? Our machine. Okay. So what are the 3 attributes? Number 1 is, you have to whether that training experience provides a direct or indirect feedback. That means in the presence of teacher. Okay. And indirect means without the presence of teacher. So this is the first key attribute, direct or indirect feedback regarding the choices that were made by the performance system. Number 1. Second is the sequence of training examples. Okay. So second is the degree to which the learner controls the sequence of training examples. Second key attribute. And third key attribute is how well we are going to represent the distribution of examples. Okay. over which the final system performance, see here again come this important factor that comes from the definition of machine learning, system performance P must be measured. ठीक है. So number one, our first key factor is direct or indirect feedback. So for example, as I have said, I am taking the example of checkers problem. So in this checkers problem, so how the system will learn? The system might learn from direct training example. Direct means in the presence of teacher, which will consist of individual checkers board state. What are the board states? What are the correct moves? Okay? And indirect means I do not know what are the moves. So indirect means indirect moves will be selected on the basis of the outcome of the various games played. Okay? So indirect means I do not know which move I have to go move now, है ना. So here comes a small little problem will come here, that is called as a credit assignment problem. What is this assignment problem? This assignment problem will come whether the move is valid or not valid. Okay? For a particular move, we can blame a learner or we can give credit to a learner. That problem is called as credit assignment, which can this is a very difficult problem that we can guess, because the game can be lost even when early moves are optimal, but afterwards the moves are very poor. So we can lose the game. So this type of problem is very difficult problem that I can say. So what we will do here, we just use, so firstly for choosing the training experience, we just learn from the direct training feedback. So we are taking the direct training feedback for designing a learning system. ठीक है ना. Now second important key is the degree to which the learner controls the sequence of training examples. ठीक है. For example, learner might depends on the teacher. That teacher will tell which move we have to move on. ठीक है ना. Secondly, there may be another option also, alternately, that learner might itself propose board state. कि what is the state, where are those dices were kept on the board. So learner will itself propose a board state and it will find particularly confusing and asking the teacher कि now what move I have to move on now, है ना. So this is little bit confusing na. So that's why we have taken the direct where the teacher is present. ठीक है. Now what happened? Now the learner must complete control over both the board states and training classification, as it does when it learns by playing against itself with no teacher present. So if the teacher is not present, then what we will do? The learner will play by itself and learn what moves are the best moves. Okay. And the third important that attribute is the that will distribute the example or which the final system performance P must be measured. Okay. And how it is measured? For example, in checkers, in this scenario, the performance matrix P is the percent of games the system wins. How many percent of games the system wins playing against the world tournament. ठीक है ना. World, we do not know who is the opponent. So if the opponent comes the world tournament winner, then we do not have moves against that winner. Then what we will do? We will definitely lose the game. So this is the important attribute, how we will represent the distribution of example. ठीक है. So by doing this, so one can master the distribution of examples which will not necessarily lead to the strong performance over some other distribution. Okay. So we will keep in mind these three important attributes while designing a learning system. Okay. Second is after choosing the experience, we will choose the target function. Target function means we will derive an equation. So according to that equation, our system will behave. Okay. So here what comes, the program will only needs to learn how to choose the best move, because we have number of legal moves. Out of those legal moves, which are the best moves. Okay. And in this machine learning, the term called as priorly, that is called as a database where all the legal moves were kept, and we have to find out the way where we can find the which is the best move out of that priorly. Priorly is the database where all the legal moves were kept, and we have to search the best search strategy, which is not known to us now. है ना? Now what we will do, we will just design a function here and we will name a function called as choose move. ठीक है? We will design a function. For example, choose move B tends to M. which will indicate a function that will accept the board input, है ना, and the moves, legal moves. Okay. Secondly, alternatively, we will find the another function called as evaluation function. Evaluation function means v, defined as v, and the notation is b tends to r. B means r means the real, the moves that we are going to move in real world. Okay, legal board moves. B, that board moves will come from the real world scenario. This is called the evaluation function. Okay, and what we will do, our intent is that this target function v will be assigned a higher score to better board state, है ना. If this target function is having the higher score, we will come to know that the board state were better. Okay. So what we have considered, we just define this target value VB as an arbitrary board state. For example, I have assigned B as a final board state. For winning, I have assigned VB is equal to 100. If the board state tends to lose, VB is equal to minus 100. If the board state is drawn, if the game is drawn, we will VB is equal to 0. And if the state, unpredictable state, we do not come to the final state, the games halts, then VB is equal to VB dash. So where V dash is the final board state. So we have considered, we have defined this target value VB for any, for example, for any arbitrary board state. Okay. Third is, after choosing the target function, we are going to represent how we are going to represent the target function. So for representing the target function, we just use a simple representation by using a calculation of linear combination. Okay. And how we calculated it? For example, I have assumed the several states x1. x1 is the number of black pieces on the board. Okay. x2 is the number of red pieces on the board. x3 number of black kings. x4 number of red kings, and x5 is how many black pieces are threatened by red, and x6 number of red pieces threatened by black. So we have defined the state here. Okay. And as I have said that we are using this linear combination, and with the help of that linear combination, this equation will be derived. Okay. By using this equation, we will going to define a target function. Okay. Which will show a linear combination. For the simplicity, we are using the linear combination. There are several approaches. Okay, we are W0 to W6 representing the numerical coefficient, which we call the weight. Okay. So after the completion of these three steps, we are just able to design the partial program, partial design. T, what is the task here? We are going to play a checkers game. What is the performance? Performance is the how many percentage of games won in the world tournament. What is the training experience? Training experience will be gained after playing games itself. Okay. And we have designed a target function, B tends to R. Okay. And how it is represented using the linear combination function. Okay. So these first three items will correspond to the specification. Keep in mind for this learning task. And last two, these two will represent the implementation. Okay. This is the partial design. Now we are just proceeding towards the final design. Okay. For final design, we need an approximation. So fourth step is how we are going to choose a function approximation algorithm. So for choosing this function approximation, we just learn the target function V cap, which will require a set of training examples. How this training example will be considered? It will be considered as an ordered pair of the form B, VB. V train B. Okay, na? What example we are taking? We are taking the checkers example. So for example, I am taking the state. For example, the training example describes the board state, and board state is described. For example, for the easy understanding, I have taken here that state B in which black has won the game. Okay, there are two opponents, black and red. So I am considering that black has won the game. So in this case, x2 is equal to 0, which will indicate that red has no remaining pieces. All the pieces were down. Okay. And the target function V train B is therefore is plus 100. Okay. So how I define this state? x1 is equal to 3, x2 is equal to 0, x3 is equal to 1, x4 is equal to 0, x5 is equal to 0, x6 is equal to 0. These are the 6. Okay. That I have represented before. These, see, these are the states now. So I have just taking the example where the black has win the game. So I have given the x1 is equal to 3, x2 is equal to 0, x2 means all the red opponents are down. ठीक है, x1, 3 pieces were left on the board, black pieces were left. ठीक है, so using this I'm just give the procedure how I have described this function approximation procedure. So firstly we will derive the training example from the indirect training experience, because indirect training experience will keep all the legal moves, because all out of those legal moves there is one best move there. ठीक है, number one. ठीक है, secondly I will adjust the weight wi that will best fit the training example. This is how I am going to approximate that function. Okay students, now for estimating the function I will just going to estimate the value. So for estimating the value I am considering that this v train, the value will be assigned ki what will be the my next move. ठीक है ना, I have just moved my dice है ना, after moving my turn, what will be the next move? I am considering that what will be my next move, that I called it successor B. So this is a simple estimate for approaching the training values for intermediate board speed on the basis of the current move. So on the basis of the current move, what will be my next move? This will be this is defined using this function. This is the rule for estimating the training value. Okay. Second is I am going to adjust the weight. So while adjusting the weight, there will be errors. So this error will be estimated using this rule. Okay. So there are number of approaches that will minimize this error. So I am using his least mean square error, LMS rule. This is the LMS rule. So according to that LMS, the equation will be E is equal to summation V train B minus V dash B. So using this rule, I am going to adjust my weights, W weights. है ना? I will just error is coming. Then I will just feedback this error back to the network, and this I will adjust the weight. Again I will calculate. This will go on iterated. ठीक है ना? On those there we have lot of legal moves. Out of those legal moves, we will choose several best moves. Okay students. So after adjusting the weights, see I am using this LMS weight update rule for adjusting the weight. ठीक है? WI, this weight is updated. WI is updated using this equation. This N is called as this is the learning rate, eta. See, there are several approaches for calculating this eta. This we will read further. Okay. So we have using an algorithm called as least mean square, that is LMS training rule. Okay. Where for each object training example we will adjust the weight here using this equation. Okay. So we will just do the approximation here. So how this eta will be considered a small constant. For example, we have considered 0.1 for the moderate size of weight update. So how this will work? This working of this update rule will be when the error, this value, this term will be 0. If this term is 0, then no weights were changed. If this term is positive, then weight will increase in proportion of the value of its corresponding feature. Okay? And if the value of some feature xi is 0, then its weight is not altered. Okay? So these are the working of this update rule. Okay? This update rule, this equation. Okay? It may be 0, it may be greater than, it may be less than. These are the working. Okay? So on the basis of this approximation, we just find out what will be the final design for this checkers problem. This is the diagrammatical representation of our learning system that can be described by 4 distinct program modules. So our first program module is defined as performance system number 1. Okay? In this performance system, we will give the initial game board situations, the new problem will be given, and this performance system will generate some solution trace that will become the history for the next move. Okay? This is the first is performance system. Okay? Second is called as critic. Okay? This solution trace is given to a critic, and this critic will generate some training examples. Okay? And those training example will be given as input to our third state, that is called as generalizer. And this generalizer will generate the hypothesis. Hypothesis means that we will get the combination of lot of legal moves, and out of those legal moves we will get some best move which will tend us to win that checkers game. Okay? It will generate this hypothesis V, and this hypothesis V will be given as an input to this state that is called as experiment generator, and this experiment generator will generate again a new problem, and this new problem will be feed back to this performance system, and this will go on, iteration will go on, iteration will go on. Okay, so this is the summary that I have just briefed you. The performance system, this is the first module, number 1. Okay students, number 2, a critic that will take as an input the history or the trace of the game. Okay, that will estimate the v-train of the target function. Okay, third module is the generalizer that will take the input, the training example, and it will produces an output hypothesis, that is its estimate of the target function. And how it is generated? Using that LMS rule that I have briefed you, LMS algorithm. Okay, where we will going to just adjust the weights. Okay, and number fourth module is called as the experiment generator. This will takes as input the current hypothesis that was generated by generalizer, and this hypothesis and the output a new problem. This will produce a new problem, and this new problem will be again given to the first performance, for the performance system, and it will explore these new chances. There are a lot of legal moves, new moves will be given, and the best move will be come out, and which will helps to win that checkers game. So this is our example. In our example, this experiment generator always prospers the same initial game board to begin a new game. Okay students, so this is my final design after these 5 steps, which can be summarized as number 1. Firstly, number 1, we will determine the training experience. Okay, so what we have assumed that we will learn by playing ourselves. Okay, games against itself. Second step is we will determine the target function. Number 3rd is we will determine the representation of learned function. Okay, and how we calculate this value? We will use the linear combination here. Okay, so we have choose the linear combination. There are several approaches we can use, but for the simplicity to understand, we are using the linear function, linear combination. And number 4 is we will determine the learning algorithm. How we learn the algorithm? Using this method, gradient descent method. There are several approaches that we can use, and after that this complete design will be generated. Okay students, so I think this will clear. So just keep in mind these 4 points, and you will just make any system to learn. Okay students, thank you very much. Thank you.